All right, welcome. Thanks for hanging in there if you're still out there. So for those of you who tuned in this summer, you probably saw us in this exact same spot doing this exact same thing. And so this is part of a solarization project evaluating different time points in the year that we can solarize the soil to try to, in this particular project, try to kill Sclerotinia inoculum. So, but we're also just evaluating soil temperatures to see what we can reach, what temperatures we can hit at 2, 4, and 6 inches. So we've got data loggers buried at 2, 4, and 6 inches under plastic for 2, 4, and 6 weeks. So we have already pulled up the 2-week and the 4-week, and we also have a non-solarized. So you can see, we started September 6th. You can see how many weeds we were dealing with, right? So the really thick one over here, this is the non-solarized. So anything with blue flags, that's non-solarized. So you can kind of tell based off the quantity of weeds. But this one, for example, where Dr. Gauthier is standing, this was the 4-week, and it is already pretty much filled with weeds. You may be able to see this here. This is the 6-week that we have not pulled up yet. And you may be able to see that there is grass pushing up on the plastic. So when we started, this entire tunnel was completely weed free from, as far as we could tell. Obviously we have a weed seed bank that we're working through, but we had tilled this very well. It had been irrigated to 70% field capacity, and it looked good when we started. And so what we're seeing here is that from a weed management standpoint, solarization in the fall is not going to work. But from a Sclerotinia standpoint,
yeah. So again, this was supposed to be a Sclerotinia only trial. Of course, we're looking at weeds because we're cycling through. And if you recall from our July field day, we have done this exact experiment in April, July, and September. So we're kind of at the end, like Dr. Rudolph said, 2-week, 4-week, and 6-week trials. So under each of these plots was the Sclerotinia. Remember, we talked about that this morning. The Sclerotinia survival structure is called sclerotia. So we put 25 sclerotia in a little envelope that we made out of like window screen type material, and we buried them at different depths. So we're looking at how hot we can get these tunnels these plots by solarizing, and how deep we can get to what temperatures. And then of course we are doing parallel experiments in the lab to determine what temperature we can kill the Sclerotinia. So that's the basis here. In April, we didn't get very warm temperatures until the end of that 6 weeks. So those last 2 weeks as we got into May. July, we almost immediately got kill at all depths. And here in September, at the very beginning of September in this treatment, we had good temperatures, but it's been cooling off, and we're hot in here now. I had to take my glasses off because they were fogged up. And so it is hot in here today, but those soil temperatures are just not getting hot enough for what we hoped for at this time of year. So we've got some data, some preliminary data. But again, we're aiming for the 38 to 40 degree Celsius,
which is about 104 degrees Fahrenheit, is about 40 degrees
right.
Celsius.
So we're aiming for anything above 104 degrees Fahrenheit. This summer in July, we walked in and it was 130 degrees Fahrenheit.
In the air, right?
In the air. So we've been kind of looking at that. But the goal is to give growers an option to solarize entire tunnels and to kill the soil-borne pathogens without the need for using chemicals. And this is very effective. So do you have some data for us?
Yes, I'm not checking my email. I'm actually looking at my notes from the temperatures. So in July, non-solarized, the highest temperature we got in April was 76 degrees Fahrenheit. That was the highest we ever reached from April 1st to middle of May.
which is not conducive
Not-
for suppressing
No.
sclerotinia,
Yeah.
much
It
less
probably
killing
just
it.
encourages it. Really.
Yes.
So the highest temperature we reached at the 2-week mark was 72 degrees at 2 inches.
Okay.
So also not hot enough.
Not hot enough.
The highest temperature we reached at, or the average, I should say, the average temperature we reached at the 4-week mark was 82. So
Okay.
we may have had enough 100 degrees at some point in time, but the average overall was about 82. So that's another thing we're looking at, right, is hitting that 104 degree mark. How many hours do we
Right.
need to hit 104 degrees and maintain that somewhere in there, right, to kill sclerotinia? Because
Right.
you may not need 2 straight weeks of 104 degrees.
Right. So just
impossible.
we were hitting that 104 degrees in the evening. So
Yes.
after an entire day of this heat, we were hitting it just for a few
Yes.
hours in the evening. So that accumulation of those temperatures as opposed to a continuous. So we're working on that part right now.
So in July, though, the average, this is fun, the average at the 2-week solarization, so early July to mid-July, 104 degrees was the average. So
Perfect.
we were up even higher if you looked at the highest temperature we reached, definitely well over 104 degrees. So
So 2 weeks in July.
2 weeks in July.
We're getting us within the range that we were looking
Yes.
for. So that's really good news for growers who were
Right.
trying to turn over crops and move on
Right.
to the next crop.
The other interesting component is that 6 weeks did not have a higher average temperature.
Okay.
So between 2, 4, and 6 weeks in the July timeframe, there's really not a lot of difference. So again, if a grower's in a hurry to turn things over and they've got, okay, I can spare 2 weeks,
Yeah.
right, in the middle of the summer, that's an option.
And we may not need 2 weeks. So
Right,
now,
you may
now
not
we
even
can
2
look at a
weeks, right,
narrower
right.
window. So again, all work that's in the pipeline.
Right. And so again, keep in mind, we're doing this from a research standpoint. So there's lots of replicates, right? And it's more complicated. But what I would envision a grower doing is getting one giant sheet
Yeah.
of plastic and sealing the entire soil off here. So it'd basically be like a sheet you would use to cover the high tunnel itself, that 6 mil poly. That's what we're using here. So it's easy to find, easy to use. You can reuse it multiple times. We certainly have. And the important thing is to seal it really well. You do not want air pockets.
So you can probably see here in this edge where we dug a very
Buried.
shallow tunnel and then we
Covered
buried
over it. Yes.
And when we did this, there was 70% field capacity. So we did irrigate before we did this. So
Right.
we do need water here. So what were our September temperatures? Do you have any
I
of
don't
those
have
yet?
that yet.
Okay.
So yeah, but
the
based
weeds
off
are
of-
telling
the
us
weeds
it's
are
not
telling
really
us
hot.
It's not hot.
Yeah.
So again, in July, there was still weed free in here where the plots had been solarized, telling us that at least that the weed seeds, underneath the soil had also been neutralized because nothing was growing. Here, it's basically we're creating a really lovely, happy environment for this grass to grow.
So remember, underneath each of these plots, we have the buried sclerotinia propagules, those sclerotia. And so we did have some viability, especially in the early weeks in April. But in July, we killed everything at all of the treatments. So again, pretty exciting that we're not just suppressing the sclerotinia in July, we were killing the sclerotinia in July.
Right.
So that's a really good thing, even at 6 inches deep.
Yeah.
And so what a cheap and fast and effective management alternative.
Right. Chemical free.
Chemical
Right.
free.
As long as you have plastic and some irrigation, you can make this work.
And to dig those trenches around each of those
Yes.
pieces of plastic. So that was the least fun part.
Yes.
So we'll be giving more data as time goes on. And hopefully that maybe next summer we'll be looking at a fusarium and maybe a southern blight propagules.
Yes.
And so root knot nematode. So we might be looking at different pathogens so that we can maybe determine how effective solarization is. But we're really excited that here in Kentucky, even in a temperate climate, we can use solarization for effective management of soil-borne pathogens.
Yep. So yeah, stay tuned. We'll be presenting on this at the Fruit and Vegetable Conference in January. So one of us will be presenting this information. So if you are interested in hearing more about that and actually seeing data up on a screen, be on the lookout for that announcement.
What about insects? What about soil-borne insects?
Jonathan,
Can we put someone on the spot?
all these weeds in here, what does that do? Is this good for pests?
It's okay for pests. Yeah. It's a lot of reservoir potential for pests. Once they get in here, there's going to be something for them to feed on. That can be a bridge for them to get from outside the tunnel, inside the tunnel. So one thing that I'm hopeful in our interactions working on this project is that I'll get to see if killing the weeds out when it works in the summertime or the earlier part of the year actually helps to cut down on aphids in particular. That's the one I'm most interested in.
So I think maybe some people wouldn't mention weeds as one of their biggest issues in a high tunnel, but I think you and I have talked about this as it's kind of one of those hidden,
I think
overlooked issues.
Yeah, it sneaks up on you. I was in a high tunnel in Western Kentucky earlier this year, and they were dealing with I think it was April, and they were already dealing with aphid pressure on some float tobacco seedlings that they had there. And he was like, I keep spraying. The company that buys my product, they don't want me to spray as much, seemingly was what he was kind of arguing. And he wanted some information. And we got down on the ground, and there was a central strip in between the areas where he grew. It had gravel. And in the gravel, there were little annual bluegrass weeds that were popping up, and they were loaded with aphids already that year, or that earlier this year. So they were just jumping off of that, getting on whatever they wanted.
So no matter how much he sprayed the crop,
exactly,
the weed was constantly providing this source.
And he had a very nice setup so that it would spray only where he needed the insecticide to go. So the central strip was never getting treated where they actually were hiding. So there was always this bank of aphids that could come out and get back onto the crop.
And so that kind of ties back into, we've talked about sanitation, right? So it's not just spraying your crop or sanitizing your crop, but the area around it and the weeds, it's constant. Everything's so close together, and it all feeds into each other.
Alternate hosts are a big deal in sanitation. You got to get rid of the things that the fungi want to live on when they're not on your plants, the plants that host the bugs when they aren't quite ready to get on your crops. If you can sanitize those out, that's a big part of it.
Right. The term that they often use is green bridge, right? So if you hear that, that's what that is like, try to get rid of your, collapse that green bridge, right? Burn that green bridge. Not literally, not literally. You could, I guess, maybe, but really you want to break that connection between that other alternative host to your crop. And whether it's pests or diseases. And
we talk about these cultural or physical methods because there's not a lot of chemical management for weeds
in high tunnels. There's really none. So it is physical. It's some sort of physical management needs to happen in a high tunnel, really and truly. Whether it's covering or pulling or something, tilling.
Weed whack them.
Weed whack them.